Spend 5 minutes on the automotive internet right now, and you'll be convinced that the golden era of pure engineering is officially dead. Purists are in an absolute state of mourning, screaming that Maranello committed total treason by dropping a V6 into a $4 million hypercar. They mock the legendary 911 for going hybrid, and they've universally declared that AMG sold its soul for a basic four-cylinder engine. But the internet is dead wrong. If you stop counting cylinders and look at physics, these aren't downsized corporate compromises. They are the most advanced factory weapons ever built, bending the laws of thermodynamics to extract numbers that shouldn't legally be possible. Welcome back to the Red Line Index. Drop your biases at the door because the raw engineering under these three hoods is absolute genius. To understand why Ferrari abandoned their sacred naturally aspirated V12 for the flagship F80, you must look directly at the global racing grid. Maranello did not downsize to save the environment. They downsized because they wanted to ruthlessly win the 24 hours of Le Mans. For decades, flagship hypercars required 12 cylinders to establish supremacy. But modern engineering requires thermal efficiency, low drag, and optimal weight allocation. The internet called it an absolute corporate betrayal. But racing history proves that Scuderia Ferrari always brings raw track physics to street cars. Under the carbon housing sits the Tipo F163CF, a 3-liter twin turbo V6 sharing a direct bloodline with their dominant endurance hypercar. By design, it is a masterclass in packaging physics. The cylinder banks are spread out at an ultra-wide 120-degree angle. This wide layout configuration tucks the twin turbochargers deep inside the V-valley, dropping the heavy engine components exceptionally low to the chassis ground. The crankshaft sits just 100 millimeters above the flat underbody diffuser, pulling the vehicle's center of gravity down to an impossible level. A massive V12 engine block would physically stand too tall, ruining the sleek silhouette and blocking the critical paths needed for aerodynamic packaging. By dropping the engine low, engineers freed up valuable room above the deck to sculpt extreme body lines that route high-velocity airflow perfectly. From this compact power unit, Ferrari extracts an astonishing 900 horsepower entirely on its own, setting a record-specific output of 300. That translates to an unprecedented 300 horsepower per liter of displacement, a number that completely shatters previous production road car records. To achieve this performance, the engine implements advanced statistical knock control, allowing it to run dangerously close to the absolute physical limits of detonation. This system raises internal combustion chamber pressures by 20%, forcing the components to withstand incredible kinetic and thermal stress loads. To survive these forces, the engine features lightweight titanium connecting rods with custom-toothed mating interfaces to guarantee absolute assembly precision. The specialized aluminum pistons utilize high-strength, diamond-like carbon-coated steel wrist pins, preventing structural failure under 3.7 bar of boost. To eliminate the massive turbo lag inherent with running that much boost, Ferrari integrated an innovative electric turbocharger solution for the very first time. A compact electric motor is installed axially on the turbo shaft, sitting directly between the exhaust turbine and the aluminum compressor housing. The moment the driver touches the pedal, the high-voltage system spins the compressor wheel to maximum speed in a fraction of a second. This completely deletes turbo lag at low revs, allowing engineers to install massive turbines optimized purely for high RPM peak power delivery. When the driver lifts off the throttle, the system reverses polarity, turning the spinning exhaust turbine into a high-capacity kinetic energy generator. This setup functions exactly like the Formula One MGUH unit, harvesting raw thermal energy from waste exhaust gases to recharge the core battery. The internal combustion core is paired with an advanced 800-volt electrical architecture, making it the most sophisticated hybrid setup from Maranello. The system integrates a front electric axle containing 2 independent radial flux motors, bringing electronic all-wheel drive capability to the vehicle. These custom front motors feature innovative Litz wire windings and a specialized Halbach array magnet configuration to maximize total magnetic field strength. Encased in carbon fiber sleeves, these lightweight front motors rev up to 30,000 revolutions per minute, providing precise torque vectoring across the front wheels. Sandwiched between the engine and the 8-speed dual-clutch transmission is a rear motor acting as an F1-style MGUK unit. This rear unit handles engine starting, torque filling during shifts, and regenerative braking, feeding power to a lightweight 2.3 kilowatt-hour battery. To monitor the high-voltage battery cells safely, Ferrari implemented a wireless sensor suite that utilizes infrared cameras to track real-time cell temperatures. The structural foundation consists of a clean sheet carbon fiber monocoque chassis cured inside an autoclave using advanced professional motorsport techniques. To minimize vehicle width and drag, Ferrari engineered a unique 1+ cabin layout, shifting the passenger seat slightly rearward into the shadow. This structural optimization narrows the upper greenhouse canopy, allowing massive visual channels to route oncoming air across the rear wings. The carbon front hood features an advanced S-duct system with integrated triplane flaps derived directly from the Le Mans winning 499P. These front wing profiles generate a massive 460 kilograms of front downforce at 250 kilometers per hour. To balance the vehicle, an active rear wing adjusts its height and angle dynamically, contributing to an overall downforce of 1,000 kilograms. To manage these colossal aerodynamic loads, an active 48-volt suspension implements independent electric actuator motors at all 4 chassis corners. The F80 is not a betrayal of Ferrari's past, but a ruthless manifestation of modern racing supremacy wrapped entirely in carbon fiber. But if you think a V6 Ferrari caused an internet uproar, wait until you see how Porsche just electrified their most sacred icon. For over 60 long years, the silhouette of the Porsche 911 has remained the absolute uncompromised benchmark for raw sports car purity. So when Stuttgart announced that the new 992.2 generation would officially become a hybrid, a collective shudder went through the community. Die-hard purists instantly flooded the internet with mocking complaints, claiming that hybridization would add massive dead weight and ruin the rear engine balance. They labeled it a glorified, over-engineered German Prius, terrified that the iconic mechanical soul of the brand had finally been sold out. But look beyond the badging, and you will find that Porsche has pulled off one of the greatest mechanical engineering masterpieces of our time. This is not a heavy, compromise-laden plug-in hybrid designed to crawl through cities on silent electric power while carrying massive battery packs. Porsche engineers designed a specialized performance loop called the T-hybrid system, which adds an incredibly lean 50 kilograms of total vehicle mass. To understand how they kept it so lightweight, we must look directly at the heart of the newly developed 3.6-liter Boxer. Designated as the 9A3, this engine replaces the outgoing 3.0-liter unit, pushing cylinder bore out to 97 millimeters. Despite the larger displacement and added electrical components, the physical height of the entire powertrain has actually been reduced by 100 millimeters. The engineers achieved this spatial miracle by completely deleting the traditional mechanical belt drive from the front face of the flat-six engine. The air conditioning compressor and the power steering pumps are now driven electrically, clearing out massive space for the high-voltage electronics. This clever deletion leaves the flat-six perfectly packaged, allowing the car to retain its legendary low center of gravity at the rear. But the undisputed crown jewel of this entire engineering marvel is how Porsche completely reimagined the physics of traditional turbocharging. In the past, the Carrera GTS relied on a complex twin turbocharger layout to generate broad mid-range torque and high horsepower figures. The new T-hybrid system rips out both units and replaces them with a single massive, high-performance electronic exhaust gas turbocharger. Normally, a single large turbocharger creates massive amounts of lag, taking forever to spool up air pressure from low engine exhaust (RPM). Porsche completely solved this physics barrier by sandwiching a compact 27 horsepower electric motor directly onto the central turbocharger shaft. Positioned exactly between the exhaust turbine wheel and the intake compressor, this high-tech motor operates on the 400-volt system loop. The instant your foot grazes the accelerator pedal, the internal electric motor spins the compressor wheel to full velocity in under 0.8 seconds. This instantaneous spin-up delivers immediate boost pressure, completely deleting lag and mimicking the throttle response of a giant naturally aspirated engine. But it gets even crazier. When exhaust gas energy exceeds what is required for boost, the electric turbo motor reverses its entire functional role. It acts as a generator, extracting kinetic energy out of the moving exhaust stream to feed electricity back to the battery pack. This incredible engineering setup mimics the highly complex motor generator unit heat found in modern multi-million-dollar Formula One racing powertrains. The second vital electric component of the T-hybrid system is embedded directly inside the newly reinforced 8-speed dual-clutch transmission case. A permanently excited synchronous motor is integrated into the transmission, supplying up to 54 additional horsepower and 150 pound-feet of torque. This integrated transmission motor provides instant torque filling during gear changes, smoothing out any minor dips in the internal combustion power band curve. Both electric motors are fed by an exceptionally compact 400-volt lithium-ion battery mounted low in the front nose section. Roughly the size of a standard 12-volt lead-acid unit, this high-tech battery holds 1.9 kilowatt-hours of energy storage capacity. To optimize overall vehicle balance, Porsche positioned this battery precisely where a traditional starter battery would sit, keeping weight distribution perfect. The combined output of the 3.6-liter flat six and the T-hybrid motors hits a massive 541 horsepower. That is a major jump of 54 horsepower over the previous model, dropping the 0 to 60 sprint down to 2.9 seconds. To manage the increased cooling demands of this hybrid setup, the front fascia features advanced active vertical cooling flaps that open and close. When closed, these flaps reduce drag significantly, but under hard track driving, they open wide to funnel high-velocity air straight to the radiators. On the Nürburgring Nordschleife, the new GTS clocked a time of 7 minutes and 16.9 seconds, crushing its predecessor by over 8 seconds. The 992.2 generation proves that hybridization can enhance mechanical sports car purity rather than diluting its historical legacy. Porsche looked at a looming regulatory wall and engineered a brilliant performance loop that turns waste heat into immediate, violent and demand acceleration. But if you think Porsche's single-turbo hybrid layout is complex, wait until you see how Mercedes completely re-engineered a legendary luxury muscle car. For over 2 decades, the letters AMG stood for one undisputed formula: a roaring, untamed twin-turbo 4.0-liter V8. It was a German muscle car defined by pure mechanical violence, tire smoke, and an exhaust note that shook the asphalt beneath it. So when a Falterbach announced the new C63 SE Performance would drop the V8 for a hybrid 4-cylinder, the internet erupted in pure fury. Enthusiasts universally declared the brand dead, calling it a tragic corporate sin to replace a legendary V8 with a 2-liter engine block. Global sales reportedly slowed down, and critics mocked the flagship sedan as a hyper-complex, overweight digital computer that lost its absolute soul. But if you bypass the emotional internet drama, you will find that AMG engineers built the most complex, physics-defying powertrain on Earth. This is not a downsized economy setup. It is a rolling engineering laboratory packed with authentic internal technology stripped straight from Formula One racing. At the core sits the M139L, which holds the official crown as the most powerful production 4-cylinder engine in entire human history. Hand-built by a single master technician, this longitudinal 2-liter power plant produces an astonishing 469 horsepower entirely on its own. That translates to a mind-boggling 234 horsepower per liter, outperforming many traditional exotic supercar engines without any assistance. To withstand the brutal combustion pressures inside the block, AMG utilized an incredibly strong, closed-deck design derived straight from Elite Motorsport. The engine blocks are chill-cast using a liquid metal process, creating an ultra-dense crystalline structure capable of managing extreme mechanical loads. The cylinder walls are lined with a proprietary twin-wire arc spray coating called nano slide, reducing internal friction while maximizing structural durability. But the technical masterpiece that allows this tiny engine to breathe is its revolutionary 400-volt electric exhaust gas turbocharger setup. Traditional large turbochargers require massive amounts of exhaust volume to spin up, creating a sluggish throttle response known as traditional turbo lag. To delete this delay, AMG integrated a tiny 4-centimeter thin electric motor directly onto the central turbocharger shaft between the wheels. Powered by the car's high-voltage battery, this compact internal motor spins the compressor wheel to full velocity before exhaust gas even arrives. This keeps air cramming into the engine continuously, giving the driver immediate, instantaneous throttle response that completely defies traditional internal combustion physics. Even when the driver lifts off the gas pedal entirely, the electric turbocharger maintains its spinning velocity to ensure on-demand boost. Shifting focus to the rear axle reveals the true genius of the E-Performance hybrid layout, featuring an advanced electric drive unit. This self-contained rear drive unit houses a powerful 201 horsepower electric motor, an automated 2-speed transmission, and a differential. By mounting this heavy electric assembly directly on the rear axle, AMG achieved a near-perfect front-to-rear vehicle weight distribution. The rear motor bypasses the main 9-speed transmission entirely, sending its electric torque straight to the rear wheels for immediate offline acceleration. However, if the rear wheels begin to slip on loose tarmac, the electronic all-wheel drive system can reroute that electric power forward. A mechanical drive shaft connects the rear unit back to the front axle, allowing the car to balance power output across all 4 tires. The automated 2-speed gearbox on the rear axle ensures the electric motor provides massive low-end launch torque before shifting up late. This secondary gear shift occurs at roughly 140 kilometers per hour, maximizing electric assistance all the way to top track speeds. Combined, the 4-cylinder engine and rear electric drive unit produce a colossal 671 horsepower and 752 torque. These absurd numbers propel the heavy luxury sedan from a standstill to 60 miles per hour in a blisteringly fast 3.3 seconds. To feed this hungry electrical system, AMG engineered an ultra-lightweight 6.1 kilowatt-hour high-performance lithium-ion battery pack assembly. Developed using direct feedback from the Mercedes Petronas Formula One team, this battery focuses on rapid power delivery rather than long electric range. The breakthrough technology inside is direct liquid cell cooling, which pumps a non-conductive coolant fluid around all 560 cells individually. This advanced thermal management keeps the battery pack at an optimal 45 degrees Celsius, allowing it to discharge and recharge at hyperspeed. While it lacks the raw, primal rumble of the old V8, the new C63 is an absolute technical masterpiece of modern engineering. It replaces simple mechanical displacement with complex high-speed computing and energy recovery loops to achieve performance targets that were once deemed impossible. Falterbach looked at tightening global emissions and decided to build a sophisticated all-wheel drive land missile packed with genuine racetrack technology. The Ferrari F80, the Porsche T-Hybrid, and the AMG C63 will reveal a fascinating, undeniable reality about the future of performance cars. The traditional recipe of adding more cylinders and increasing raw engine displacement is officially hitting a dead end due to global regulations. But instead of waving a white flag, factory race engineers are using physics, software, and electrification to build even faster weapons. These 3 masterpieces show that true mechanical innovation thrives when the rules become tough, pushing the boundaries of automotive potential forward. The internet comment sections will always complain about lost exhaust sounds, but the stopwatch on the racetrack never tells a lie. If you appreciate raw, uncompromised factory engineering analysis, without the generic clickbait drama, smash that like button on your screen right now. Subscribe to the Redline Index and hit the notification bell so you never miss our deep dive technical documentaries on elite performance metal. Drop your thoughts on these 3 hybrid engines in the comments down below. We will see you next time at the Redline.